Hey algebra students, in this lesson we are going to be learning about determining theoretical probability. Now you might remember in investigation 1 we already learned about probability. We started talking about what it was and calculating some basic probabilities. This lesson is basically just a review of that. What is probability? Probability is a measure of how likely a given event or outcome is to occur. And we usually measure probability and express it as a decimal, a percent, or a fraction. And honestly, in algebra, the most common way of expressing a probability is a fraction. So you probably should just express it that way unless you're asked to do it a different way. Now, there's some other terms related to probability that we need to review. But in order for us to understand those terms, we need to think about an event that is a probabilistic event. Okay, so I want you to think of flipping a coin, and we're just going to constantly go back to the idea of flipping a coin throughout this lesson. When you flip a coin, there's two possible outcomes, heads or tails, and there's a 50% chance of either of those outcomes occurring. When I flip a coin, there's a 1/2 probability that the outcome is going to be heads and 1/2 that it's going to be tails. Now, when I just described that event, notice that I said that there were possible outcomes for an event. I'm missing a letter here. So the set of all possible outcomes for an event is known as the sample space, and we usually write it out using set notation. So if I was to list the sample space for flipping a coin, it would be squiggly bracket, heads, comma, tails. This is the sample space for flipping a coin, the possible outcomes of that event. If I was to do the same thing for rolling a dice, for all possible outcomes of rolling a dice, it would look the same. It would be 1, 2, 3, 4, 5, 6. That's the sample space for rolling a dice. A simple event is an event that has only one outcome. So rolling a 3 on a dice would be a simple event. Rolling an odd number on a dice would not be a simple event because there's 3 possible outcomes that satisfy, three favorable outcomes when I say rolling an odd number or an even number on a dice. Theoretical probability is found by analyzing a situation when all outcomes are equally likely, flipping a fair coin, rolling a dice. It could be pulling a card out of a deck of cards that has been fairly shuffled. All outcomes are equally likely, and then finding the ratio of favorable outcomes. Now this is the key. It's not favorable to unfavorable. Don't confuse it. Don't accidentally put the count of unfavorable outcomes on the bottom. It's all outcomes. So it's a ratio, a fraction with favorable outcomes on top. So when I say flipping heads, there's one favorable outcome, heads. That's a simple event. When I say rolling an odd number on the dice, there are 3 favorable outcomes I put on top of my fraction. And then on the bottom of my fraction has all possible outcomes. I count the number of outcomes in my sample space, and I put that on the bottom of my fraction. One other thing, I don't know how much this one matters, except that it comes up sometimes in the assignment. A complement of an event is the set of all outcomes that are not a given event. So the complement of flipping heads on a dice is flipping heads on a coin is flipping tails on a coin. The complement of rolling a 2 on a dice is rolling a 1, 3, 4, 5, or 6 on a dice. Okay, so the complement is the outcomes that are not the outcomes that I'm looking for. Let's do some practice problems so you can see how this works in real problems. So for the first 3, A, B, and C, a number cube labeled 1 through 6 is rolled. List the outcome for each event. Okay, so I'm listing the outcome. What am I looking for? A number less than or equal to 4. The possible outcomes would be 1, 2, 3. That's what I need to list for letter A. That, by the way, would not be a simple event because there are 3 possible outcomes, not just 1. Letter B, an even number. Why, that would be 2, 4, 6 would be the possible outcomes. That would be an even number. And letter C, a number greater than 2. Why, that would be 3, 4, 5, 6. There's 4 possible outcomes for that event. Okay, so these are how you would write them. Notice I wrote all of these in set notation. It's important to use set notation when you're writing out these sorts of problems related to probability. Letter D, what is the probability of randomly choosing a blue marble if there are 4 green, 3 blue, and 3 red marbles in a bag? So the question is, how many favorable outcomes are there? Well, there's 3 blue marbles. Picking blue is favorable. And then on the bottom of my fractions, how many possible outcomes? 4 plus 3 plus 3 is 10. So the answer here would be 3 over 10 for letter D. What is the probability of randomly not choosing a red marble? Okay, well, first of all, I have to consider what is the complement of choosing a red marble? It's choosing a blue or green. So blue and green marbles would be not red. I'm going to put the total number of not red marbles, 7, over the total number of marbles. The answer to that one is 7 over 10. Next, suppose there are 8 balls in a bucket, numbered as follows. 1, 2, 3, 5, 5, 6, 7, 7. Why are they numbered that way? Who knows? But a single ball is randomly chosen from the bucket. What is the probability of drawing a ball with a number less than 6? Okay, now let's pick apart this language here. Less than 6 is not less than or equal to 6. So 6 doesn't count. It has to be one that's actually less than 6. So how many balls do I have with numbers that are less than 6? 1, 2, 3, and then both of my 5s, that's 4, 5. I have 5 balls with less than 6 and a total of 8 balls in the bucket. So the probability less than 6 is 5 over 8. And then what is the probability of drawing, let's see, do you have a greater chance of drawing a 7 or a 6? I have a greater chance of 7 because there are 2 7s but only 1 6. Probability of drawing a 7 is 1 out of 4, or 2 out of 8. Probability of drawing a 6 is 1 out of 8, which is the smallest probability here. And then letter G, a 52 card deck has 4 kings in the deck. What is the probability of randomly drawing a king out of the deck? Well, it would be 4 out of 52. I have to simplify that fraction. 4 goes into 52 13 times, so this is the same as 1 out of 13. There's a 1 out of 13 probability of randomly drawing a king. All right, that's how you do these sorts of probability problems. Keep in mind there's going to be probability problems from this lesson and probability problems from investigation 1 that you're going to be responsible for. Make sure you watch for those in the problem set 1 through 30.